Hi everyone, welcome to our first lesson of online learning. I just want to tell you before we start, I really miss seeing all of you. I have so enjoyed our Algebra 2 classes. I'm very grateful that we have this platform and this way of keeping in touch and doing some online learning. So we are lucky that we do have this technology. So I'm going to do the best I can. If you have any suggestions, any glitches, anything I should know about, please let me know. So let's get started. What we're going to be talking about today is finding the zeros of a polynomial function. And this lesson is going to be broken into two. So what you're going to get today is just the beginning of it. So remember, when we're looking for the zeros of a function, we're looking for where does that polynomial function intersect the x-axis? Or, in some cases, it may have imaginary roots. So in this case that I just drew, it's a third-degree polynomial function with only one real root and two imaginary roots, or complex roots. So, we have already discussed the fundamental theorem of algebra, and we've already been using this corollary. So we're going to jump right in, and we're going to start talking about Descartes' rule of signs. Now, Descartes' rule of signs will allow us to kind of focus in on what kind of roots we might have for our function. So in other words, do we have positive real roots? Do we have negative real roots? Do we have imaginary roots? Like, what combination of those roots might we have? In order to use Descartes' rule of signs, we need to make sure that our polynomials are written in descending powers of x. So x to the fifth, x to the fourth, x to the third, and so on until we get to our constant. What we're going to be doing is we're going to be looking for the sign changes. In other words, how many times does our polynomial function, do the terms bounce from positive to negative or negative to positive? That's going to be the key to today's lesson. So we're going to jump right in. What we're going to first focus on is how many possible positive real roots our function may have. And all we need for this is to look at our given function and look for how many times it bounces from positive to negative and back to positive. So these two terms bounce from positive to negative, and we go from, oops, that was Jerry shaking, from negative to positive. The two terms that are next, x to the third and x squared, are both positive, so there's no sign change there. But from x squared to the x term, it bounces from positive to negative, and from the x term to the constant, it bounces from negative to positive. What that means is we may have 4 positive real roots, or it might be 2 less than that. So we might have 2 positive real roots, or it might be 2 less than that. We might not have any positive real roots. Now, we don't go into the negatives here, so once you get to either 0 or 1, that's it. You stop subtracting 2. Okay, so the next step is to look and figure out how many possible negative real roots we may have. This is done in a very similar fashion, but what we do is we substitute negative x in. So we do p of negative x. Now, if you want to make your life easy, what I want you to do is I want you to underline every term that is raised to to an odd power. So we have x to the fifth, x to the third, and x to the first. All of those terms will change signs. So x to the fifth goes from positive to negative. Negative x to the fourth will not change. X to the third goes from positive to negative. Positive 9x squared will not change. Negative x to the first becomes positive, and of course positive 5 is not going to change because we're not even substituting anything into that term. What you can see is we have exactly 1 sign change. So now what we do is we match up every number for our possible positive real roots with every number from our possible negative real roots. We're going to put them in our chart here. So we have 4 and 1, 2 and 1, 0 and 1. Because this is a fifth degree polynomial, we will have 5 total roots. So in order to make these numbers add up to 5, we kind of fill in the gaps with a number of imaginary roots. So 4 plus 1 plus 0 equals 5. That's one possible scenario for our roots. 2 plus 1 plus 2 equals 5. 0 plus 1 plus 4 imaginary roots equals 5. And that's it. We just figured out the possible combinations of positive, negative, and imaginary roots for this particular function. All right, let's do another one. So remember, first we look for the possible number of positive real roots. Look for sign changes here. Positive to positive to positive to negative. Boom, there's a sign change right there. So we know we will have exactly one positive real root. Next, we look for the number of negative real roots by doing p of negative x. I'm underlining my odd terms. So x to the third goes from positive to negative. X squared, 4x squared doesn't change. 3x to the first becomes negative. Negative 2 does not change. This means we have possibly 2 negative real roots, or subtract 2 from that, we might not have any. Let's go ahead and look at our chart. Match up all of the possible number of positive real roots with all of the possible number of negative real roots. All right, think about it. What should these add up to? This is a third degree polynomial, so these should add up to 3. So go ahead now and fill in the gaps. 1 plus 2 plus 0 equals 3. 1 plus 0 plus 2 equals 3. So a little bit shorter of a chart. There are only 2 possible scenarios for this particular polynomial function. Let's turn the page. So remember I told you we're only going to do part of this lesson. So what I would like for you to do right now is we're going to talk about this tomorrow. You're going to just use Descartes' rule of signs to figure out how many possible positive, negative, and complex or imaginary roots we might have. Now the chart that I would suggest you make, I like to make this little chart over here. Positive, negative, and imaginary. Keeping in mind, these should add up to 3. Okay, so what I want you to do right now is I want you to pause the video. I want you to see if you can figure out how to do this and what the positive, negative, and imaginary number of roots might be. And then I want you to turn it back on and see if you got the same answer as me. I think you're going to do it right. I have confidence in you. You've got this. Okay, go ahead. Pause it, do it, and check back in. Okay, how did you do? Hopefully you got the same chart as me. Okay, if not, go back and see maybe what you did wrong, see where you made a mistake. And what I want you to do for homework is worksheet 7.5a. But for 1 through 5, all I want you to do is make the chart that we just made. Tomorrow, we're going to come back to this, and we're going to kind of build off of that. Now, I'd like for you to submit this to me by 7 o'clock tonight. You can take a picture. You can email it to me. I will check you off. I am going to be checking homework through this process. I want to give you credit. So if there's an issue, if there's a reason why you can't do it, if something comes up, obviously these are different times than usual. So please let me know. But I really want to make sure you keep up the work because we're going to be moving on tomorrow. Okay? Good luck. Again, I miss you. Wash your hands. Be safe. And I will see you tomorrow. Bye.